everyone? Let's get underway. All right, welcome to, week 3? So this will be week 3 and then 10 to go after that. So semesters tend to be pretty short, yeah? There's a lot to pack into them. Has everyone hopefully every group should have finished their PDS, yeah? Most groups should be almost complete with their research briefs, or whatever we were calling that. Tomorrow's tutorial, you'll have a brand new brief to be completing that'll be based on what we talk about today, okay? So you can see that if you don't get on top of your work and be filling that 10 hours a week, then you can very quickly get behind, all right? So if you have not completed that research brief, I highly recommend you spend some cycles on it tonight, such that by the time we get to tomorrow, you'll be ready to go on the next one, and then you have sort of the next week to fill that out, and then we'll be getting pretty close to building some designs and testing them out. Okay? All right, so today, lecture before last, we defined the problem. We all talked about that. So step 1, and we did that. Step 2, that was last lecture. And we were talking about research and experimentation, literature review, and you should be all ticking along with that. Does anyone have any questions on research brief or anything that's come up in the last week of them doing study on it? No? Pretty much under control. Pretty simple stuff. There's not a lot to actually be sourcing, so you should be able to find it pretty easily on Google and Wikipedia and whatever else you're using. If you have any questions, feel free to come and talk to me about it. All right, so today we will be talking about step 3. Who's come up with a bridge design already? Anyone? Some groups? Starting to think about it? So you don't do step 1 or 2 in a vacuum. Ideally you do step 1 or 2 before you have any complete design ideas. You do them to try and drive you towards design. So particularly step 2, if you're looking up at different options and different material and you're starting to summarise and choose which material might be best, that's feeding into step 3. That's feeding into the designs that you're going to be doing, okay? So step 2 isn't just research with blinders on. Step 2 should be carried out in context, all right? Research, when you're talking about the design process, is always carried out in context. So I'm doing research, but I'm doing research for a very specific purpose, and that is to inform my design. All right? So as a result of what you're writing up on step 2, you should be pretty close to at least what style structure you might want for a bridge. You'll have analysed how they carry loads, or at least thought about the load paths, and realised that perhaps a suspension bridge isn't the right bridge for this application, maybe a truss bridge, maybe a beam bridge, something like that, yeah? So you'll have started to refine your scope purely based on the research and what you know is and isn't applicable. Hopefully you've also got a bit of an idea of what materials you might want to use based on how strong it is, how light it is, how much it costs, and how readily available it is to you, okay? So the research phase is looking at information that exists, but it's informing design based on what you get from that, okay? So you should be at a really good, solid starting point to move on to stage 3, which is, all right, we know what's been done before, we know roughly where our design's going to be, we know roughly what material we might want to try. Now let's come up with some specific solutions or ideas or, design incarnations, and see which one of those might be the most appropriate through testing, analysis, experimentation, and so forth, okay? And so that's what we're going to talk about today. There's really a few facets to the generating a solution area, one of which isn't on those 4 points, is you want to generate multiple solutions, okay? It's no good just coming up with one. If you just come up with one solution, then you're going to pigeonhole yourself, all right? It might be that you come up with 3, you might come up with 5 ideas and try to make them as different as possible. Because if you go down the design path a little bit further with each of those designs, even if you've got a really crazy outside the box idea on this side, a little bit of work on that might actually give you information that feeds into the sensible design at number 1 or 2, all right? So thinking outside the box, thinking all of your different options is really useful at this phase of the design. All right, so I suggest probably a minimum of 3 design solutions. And then you might refine that to, all right, I like this one out of 3. Let's come up with 3 sub-ideas, yeah? So, all right, we're going to use a truss bridge and we're going to use this type of material, but do we have large structure, small structure? How is it going to, feed off itself? So that kind of thing. So you use multiple ideas or options, because then once you think through them, test some things, then that'll actually give you much more information than just going one and trying to make it work. Engineering's not about just choosing one solution that seems right and moving on. It's about understanding why you're choosing that solution. And this phase is sort of the fun phase. It's before you get to the nitty-gritty of analysis, but it's after all of the research stuff. So this is where you get to be creative. You get to do brainstorming. You get to do sketching. Who likes sketching? Some of you? Who hates sketching? Some of you? Okay, so engineering uses sketching. All engineering uses sketching. We're going to talk about drawing in sort of the second part or middle part of this subject. I'm going to give you some really useful tools to help you sketch. In the meantime, you're just going to sketch as best you can on this project and start to think where sketching could be useful, where you need some work, and then I'll give you some tools to help you sketch. Hopefully by the end of the subject, everyone's at least a little bit more comfortable with sketching, because sketching's so useful when you're actually doing this phase of a design project. And I'll talk about quick prototyping, and we'll have a bit of a video on that. All right, so creativity. What do you think creativity is? Anyone? Yeah, so thinking outside the box, coming up with solutions. What else? So what is a really, really creative profession, in your opinion? Music? So musicians can be creative? Art? Yeah? Architects? Yeah? Anything else? Engineering. Funnily enough, engineering is an amazingly creative profession, but you don't really realise that amongst all of maths and physics and things like that. But you've got to come up with solutions. So you've got to actually use creativity, and we'll foster that creativity throughout the degree. So effectively, creativity is playing with imagination and possibilities, leading to a new and meaningful connections and outcomes, blah, 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 while basically interacting with all of the different things that you've got at your disposal. So that might be people and ideas and the environment and all other sorts of things. Now, creativity is always best if you start with existing solutions. So musicians are very creative, but they don't reinvent music every time they make music, yeah? You might start with a particular scale or a particular rhythm or a particular style of music. It's working within some sort of a box and then using that to be creative. And sometimes you get people that are super creative that reinvent a genre. But for the most part, really good music sits within some sort of a facet and then creates on top of that. Engineering's exactly the same. So you need to potentially start with an existing solution, like an existing solution that might have something wrong with it, or that doesn't solve the problem, or that other people have tried that you don't like and you think you can do it better. And really focus on improving weaknesses. So that's one area where you can start to be creative, but within a box. And there is no correlation between creativity and intelligence. I've put that up there to really emphasize that it's not, creative people aren't necessarily just the smart people are creative, or the people that don't get high marks on maths, maybe they're the creatives as opposed to mathematicians. There's no correlation at all. Everyone can be creative. If you don't feel like you're a creative person, it's something that you can build in yourself. It's something you can learn. And effectively, you need to make a conscious effort to be creative, and you start to put in some of these systematic processes. So you go through the motions and the sorts of things that I'll talk about, and you can start to be creative even if you thought you were not creative at all. Everyone's got creative potential, and effectively, if you don't exercise it, you're probably not going to be very good at it. But if you try to exercise your creativity, you'll become better and better at it until you become an excellent design engineer. Okay? So you guys are going to need to be creative on your bridges, you're going to need to be creative on your pumps, and you're going to have lots more opportunities to be creative throughout the 4-year degree. And part of the way to be creative is to work with people. So when you're brainstorming and working in a group, that actually helps people to be creative. All right? When you're working in a group, you might not be able to sit down by yourself and be super creative, but if someone else says something, that might spark something in your mind and you work off each other. So one of the easiest ways to boost your creativity is to actually work in a group and do brainstorming and that kind of thing. It's really important, particularly for creative thought, when you're in that group, to remove all judgment. All right, so if someone comes up with something, it's incredibly important for everyone to focus on not judging them or saying, no, that's stupid, what are you thinking about? You know, that is a really negative way to react to something. And the most important thing is if someone comes up with something really left field and out there that sounds stupid just off the bat, that might actually suggest something to someone else and they might come up with something as a result of it. It might not be the same thing, but it might drive some sort of creativity in one of the other group members. And so if you start setting up your group culture to be really negative or judgmental when someone comes up with something a bit silly, then people are going to stop saying things. All right? And that's going to kill the creativity in your group and you're going to lose it. So it's really important for everyone to go in there and have a really open discussion and make sure there's no judgment. All right? Judgment will kill your creativity. Document everything. Now, when you have a group session, particularly in this phase of the project, I insist that you have a scribe or someone writing down what you say. Because if you spend half hour or an hour with everyone throwing ideas out there, you get to the end and you go, oh, geez, you came up with, what was that idea that you came up 10 minutes in and you've forgotten it? You've lost it. Yeah? We live in an age of technology, so at the very least you can set an iPhone up on a table and record the thing. Yeah? But what you should do is have at least one group member, and you can cycle it around. If you don't like writing down, then everyone take a turn at each different meeting. But you write down the dot points or the ideas or the suggestions. It's really important. And then at the end of a group meeting, when you come up with you do this, you do this, you do this, you write that down. Because at the next meeting, then you're going to say, all right, so you were going to do this. Where's the progress? And it's all written down there, and everyone knows their obligations. So it's very important to write that sort of stuff down. Plan your brainstorming activity. So don't just sit down and start throwing ideas on the page. Plan what you're going to do and when and how that's actually going to proceed. And this is a suggestion. So you limit it to 30 to 60 minutes because after that you'll just be pretty much useless. Your brain will be run out of puff and you won't be putting anything useful on the page. It's much better to spend 60 minutes now, go away for a day or go away for an hour, come back to it with fresh ideas, because a lot of what you talk about in that 60 minutes will actually kind of marinate in your head, I guess, over the time that you're away, and then you come back with better ideas. Okay, so take a break between them. Probably first 5 minutes, discuss the problem. What are we doing? What are we actually trying to achieve here? 20 minutes of raw idea discussion, no criticism, no assessment, no nothing, just throwing ideas out there and trying to evolve them towards what you want it to be. 25 minutes of assessment, so idea assessment, and I'm going to give you a methodology by which to assess your ideas. But so the 20 minutes before, you're coming up with all these ideas and you might resolve them into 5 or 6 different ideas, and then you spend 25 minutes talking about how are they good, how are they bad, how could we make them better, that kind of stuff. And then the last 10 minutes is to summarise that and maybe move from it. So if your assessment chose 1 or 2 ideas and you kind of evolved it a little bit, now you've got another 10 minutes just to try and get that consolidated, get your design together, and then walk away. Come back to it an hour later, 2 hours later or something, and maybe evolve it a little bit more. But if you plan your time like that and you time it, you'll have a really productive session. If you just sit there for an hour throwing ideas out there and everyone talking over everyone else, it's going to be really, really unproductive. Now the other thing is, you guys as a group, and this speaks to group skills, you guys will have some members that are really keen to talk all the time and some members that are really keen to listen all the time. All right? So it's up to you to work out how to manage your group. If you need to have a speaking hat, have a speaking hat and hand it around, or a stick, or the speaking pen where everyone gets a particular amount of time to voice their ideas. If you've got someone who's what you might call a born leader in a group, it just tends to be that they talk more. And so that's effectively one person's brainstorming. What you want is 5 people's ideas. So if you find that your group discussions are being a little bit one-sided, I know whenever I'm in the group I tend to be the loudmouth and talk a lot because it's just my nature. You need to let everyone have a go. And so if it's not natural to do that, then have some sort of mechanism that allows it in your group. Now that's going to apply for that 20 minutes of raw idea discussion. Okay? Draw down ideas, sketch ideas, talk to each other, make sure everyone has an equal say, because the next 25 minutes we're going to apply this 6-hat idea. And the 6-hat idea actually ensures that everyone gets their say, because everyone has to put on a single hat and then contribute. And we're going to have an exercise on this in 2 seconds once I explain what each of these hats are. Alright, so you've got 5 people in your group. That last hat, the blue hat, is the one that makes sure everyone's actually doing their job. So that's one that can probably double up for someone. So someone actually mediates and also they'll have one of the other hats, okay? So you've got 5 in a group, then there's 5 hats plus someone making sure everyone's doing their job. White hat. The person who's wearing the white hat looks over the ideas you've come up with in the last 20 minutes and they work out, write down, you can do it individually or in the group together, write down all of the facts or what we would need to know to really validate an idea or execute it. What do I need to know about this idea to really get it to where we need it to go? And that white hat person might look over each one of the designs and come up with the sorts of information you'll need to source to make the design work. All right? That's the white hat person's job. Yellow hat. Everyone likes the black hat actually, but the yellow hat's good because the yellow hat symbolises brightness and optimism. Basically, you're the one coming up with all of the positives of a design. So you look over each design and you come up with all the pros. What would the design do really well? And write that down. All right? You are the pro person. No pessimism, no pragmatism. Hands up who's an optimist. Hands up who's a pessimist. Hands up who's a pragmatist. All right? Does anyone know what a pragmatist is as opposed to the other two? No? So you've got an optimist, you've got a pessimist, and...
But pragmatist is good, whereas an optimist looks at the good side and a pessimist looks at the bad side, so half a cup. So, like, optimists look at it and say that's half full, pessimists look at it and say that's half empty.
Yep.
And pragmatists look at it and go that's half full, what do I contribute?
Yeah, potentially. So a pragmatist is basically able to walk both lines, all right? So you can see all of the positives, you can see all of the negatives, and you balance them, and every engineer should be a pragmatist, all right? Now, in this particular circumstance, we're going to have an optimist and we're going to have a pessimist, and all of you are probably going to play that pragmatic role and make an assessment based on that. But the yellow hat is the optimist, and then we've got this black hat. Black hat is judgment. Everyone loves being black hat. Black hat is devil's advocate or someone... You know, why won't it work? What's wrong with it? What will be bad about it? Where will it break? How much will it cost? Why does the idea suck? Everyone loves poking holes in other people's ideas. It's just nature for some reason. So black hat gets to do that. Red hat signifies feelings. Hands up who likes talking about their feelings. A couple of people. So red hat signifies feelings, and that's not necessarily, oh, the design makes me sad. It's more how you react to a product and how feelings might actually work in a brainstorming session. So if you're talking about a car, then you'll have a lot of feelings around ergonomics or about how safe something is or that kind of stuff. You look at a design and you actually get some emotional response to it. It's harder to interpret, but it's an important aspect of design and it should be considered. And so the person who's wearing the red hat gets to do that, and we'll do that in a second as well. And then the green hat focuses on creativity or possibilities. So, all right, that's a cool design. What could we do with the design? All right, it's good, but what if we did this or that, or what are the possible options? Where could we go with this particular design? All right, and the idea of the brainstorming session is that everyone puts on a hat and goes off and assesses these designs and then comes back together and discusses it. So you might spend 15 minutes doing that individually, come back together for the last 10 minutes and discuss all of those options. And at that point you can add to each other's lists, and at the end you use that discussion to refine your designs. Now, this is important. You don't get to be black hat every single time. All right? we have to rotate the hats. You can either rotate the hats in a single session or in subsequent things, but it's like the talking stick, yeah? So if you've been black hat this time, next time you're yellow hat or your red hat. Everyone has to have a go at each hat because everyone in their right, firstly you need to learn how to do each of these because if you're by yourself you need to be all 5 hats or all 6 hats. But secondly, everyone has really valuable contributions. And so if you're always the pessimist and someone else always has to be the positive person, then that's not fully doing justice to the group work. You need to optimize everyone's contributions. Okay? And so rotate this. It's really important for everyone to have a go at this. All right, what have I got there? That's a shopping trolley. What's it made out of? Plastic, yeah. So, your job for the next 10 minutes, we're going to apply those 6 hats and remembering that the last hat is technically managing the process, so I'm not expecting anyone to oversee yourself of the process, so we won't have that last hat. I am Tajay, and I'm a design engineer, and I've just come up with this idea for a plastic shopping trolley. And we're going to assess this particular design of a plastic shopping trolley based on my 6-hat categorization. So, I'm going to break the room up into hats. What have we got? All right, so white hat, just the facts. What would you need to know about a shopping trolley? This side of the room, up to you two guys. You guys are back with these guys. So everyone forward of that. You guys in this cell here, you're discussing amongst yourselves, white hat for my shopping trolley idea. All right, yellow hat is you 5 guys back and probably this row back here, okay? So you guys here, everyone understand? Not you guys over that side, just you guys here and you guys here are white hats. All right, so this row down to you guys here, you guys get to be, what did I say? You're up to black hats. So you guys get to be negative. Poke holes in it. Very good. All right, you guys in this row to here. Including you guys up to this row. You guys are red hats. Okay, so you guys are doing feelings. And we'll talk a little bit about that. But you guys need to work out what that shopping trolley invokes in you and feelings, respect to how you would use it, how safe does it look, what emotion does it invoke. And you guys back, everyone in this back corner of the room, you guys are green hats, creativity. Where could you go with the design? All right, so does everyone know which category they're in, which hat they're wearing currently? Mostly? Sorry? Are you what? Move? No, you stay right where you are. Alright, so spend about 10 minutes. I'll leave the definition up on the board. Does everyone have a nice searing image of the shopping trolley in their head? Actually, I'll pull up that thing and put it on a different slide, the red hat, the hats. So think about the shopping trolley. Spend 10 minutes talking amongst yourselves in relation to your hat. And I'll pull up the hat thing in a second. All right, has everyone had a chance to talk about that, think about that, write some ideas under their hat? All right, so let's talk about them. Okay, so we got this plastic shopping trolley. White hat people, what sort of information are we going to need? Where do we say? Over here? Yep.
How durable is the plastic that they use?
Yeah, so plastic, there's a worry about its durability, so how durable will that plastic be is absolutely information you need. What else? Cost, how much is the plastic going to cost compared to, say, a traditional wireframe type trolley?
Is the plastic going to be thermosetting or plastic?
Yeah, thermosetting or thermoplastic, so will it be basically able to melt in the sun, I suppose is where you're going with that, yeah? Or if someone tries to set it on fire, and I guarantee you someone will try to set it on fire, will it burn? What else? Anything? Yeah, so how will it break and how likely is it to break when compared to a traditional trolley? Is that going to be a downside to it? Was there another one up there? Yeah, so what safety standards might exist for children's seats? That's a good one. So it's got a children's seat in it then. The last thing you need is a children's seat to break and try to squash the child. So I'm sure there's some amount of standards there involved. What standards are they? Anything else? What other information might we need? Yeah, so what's the trolley going to do? If it breaks, can you recycle it? If it gets thrown in a creek, will it degrade or be there forever? Or will it poison the creek for that matter? Anyone else in the rest of the room think of what we might need about a trolley? White hat?
Will it be just straight plastic, or will there be any type of coating on top of it?
Yeah, so are we going to treat the plastic? Will it have a coating on it? What other materials are in there? Probably steel and things in the actual axles and bearings.
How does the steering compare to this one compared to the old one? Does the steering have that fixed?
Yeah, so will this steer better, worse or the same as an existing trolley? So there's lots of information there that we need to then refine or find out when we're actually going to the next phase of design here. So that's a useful thing. Yellow hat. Where am I? Up the back there. What's great about this design? Yeah, so you can see what you've got, which is useful. Now, I don't know if that's an improvement on existing trolleys or just a status quo, but that's a pro. That's very optimistic, though. Points for that. All right, another one. More customisable? Yeah, so what, in terms of colour, logos, that kind of thing? Yeah, so one advantage of this is that Target has got their pretty Target colours all over it, and they've got their Target logos on it, and they can do whatever else they want with it. So this looks like a Target trolley. It might actually even define the shop based on what the trolleys look like out the front of it. That's quite useful. What else? Yep, yeah, so it stands out. It might be easier to find in a car park if you're collecting them and that sort of stuff. Also, I suppose if you just pinched it and walking down the road, it's not a nondescript wire shopping trolley. You know full well that you've just stolen a Target shopping trolley. That might be useful. What else? Any other positives? A light material, yeah. Now, depending on what the material actually is, then it might be... Could it be cheaper than steel, maybe? Probably. Yeah, so you might be able to mould this rather than weld it, and so it might be cheaper to manufacture, might be an advantage. Any other pros for this design? Oh yeah, it's got handles all the way around. That's pretty cool. Yeah, that's good. See, they're thinking. That's good. That's a nice positive. All right, anyone else in the rest of the room got positives about this design? All right. Oh, there was one there.
It's a very lovely shade of red.
It is very nice red, yes. It's a lovely colour. Sorry?
Since it's made out of plastic, you can probably 3D print yourself.
You could potentially 3D print one, yeah. Cool. All right, so black hats. This is the fun one, black hats. Why is this design garbage?
It still looks like someone put a piece of Lego together.
It looks like a Lego.
It does. I don't know whether or not that will basically snap with the red and white bar.
Yeah, true. I mean, if Target's trying to sell Lego, maybe that's a good thing. But yeah, it does look a little bit kid-like, doesn't it?
All the holes everywhere around the trolley, like if you've got a small object, it can fall through the hole.
A small object could fall through those holes that were, until just now, a positive. Now they're a negative. Yeah?
Also, yes, the whole part that we don't know that whether or not where the colour means is that singular piece. If it's not a heavy load on the front, you just have the trolley.
Yeah, so particularly, is my mouse going to show up here? Particularly there.
Yeah, right there.
That's obviously a join between two colours. Could that snap there, or is that a structural weak point? It's certainly going to be the highest stressed part of the whole trolley.
Using plastic, it's going to be like over time the strain of your annoying little kids jumping in the front of your trolley, it's just going to snap it real quick.
Potentially, yeah. Now that I suppose requires the engineering to be done on whether this would last longer than steel, because steel fatigues as well. What's a negative with the actual material? Plastic can go brittle, yeah? Plastic can melt in the sun, yeah, so you'd have to be very careful about what sort of plastic you used. Colour would fade, yeah, so plastic has a really bad UV resilience. So you can get UV resistant plastics, but still the plastic fades. Think of your pegs on your clothesline if you've got plastic pegs. They've got UV stabiliser in them, and all of them end up a really light shade of garbage by the time they're old. So UV stabilised plastic is critical, and it can still probably degrade. Anything else? How do you know it's plastic? Well, it could be, but I told you it's plastic, so that's a fairly safe bet. Let's pretend it's plastic for this argument, and then we'll... I mean, what you might do is say, all right, if the plastic's going to break, we'll put steel on the inside of it. But then there's a whole manufacturing process involved in doing that might be less than ideal. Yeah, potentially. Is that steering any good? We've got a fixed rear wheel, so that could be a problem.
The way the trolley is set out is spatially annoying. So once again, if you've got a kid, like the seat looks like it takes off the top area of the trolley.
Yeah.
Like anything bulky that works fit underneath, you can't actually put it on hold.
Yeah, that's right. And that's a negative, but I would also put that under the emotional category as well. So it just feels like it's kind of cumbersome and bulky there.
Also with the kids part, we can't see that back seat is properly stabilised, so we don't know what exactly is going to happen. If you've got a really big kid, that you can probably
A really big kid, yeah. Yeah, so how strong is it? So just a general worry that plastic isn't as strong as metal in most of these circumstances. Does anyone else in the rest of the room have some negatives about this trolley? One over here. Yeah, will they concertina it together? Maybe, maybe not.
So if the seat is meant to come down and there's no actual back support, so the baby could just be like, wow, pull out the back and hit its head on the bottom of the trolley.
That could be a problem, yeah, absolutely. Just behind you and then you.
It's a terrible looking design.
It looks bad, so that goes in the emotional category again, but yeah, it's a bit of a rough looking design. Yep.
Also, the way that the back wheels are, again with the heavy load, will certain amount of load may catch that as well.
Yeah, so the back wheels are cantilevered, so that could be a problem. Engineer it and it shouldn't be. But one major one is it's made out of plastic. What do we make plastic out of? Oil. Yeah? So, unless you're talking like eco-plastic, and maybe this is made out of eco-plastic and everyone's super happy and proud of their eco-plastic trolley. But for the most part, the cheap stuff, if you don't want to pay $1 million for a trolley, this will be made out of oil. And in our current climate, your business going to an all-plastic trolley as opposed to something made out of steel, that could actually be a PR nightmare because now you're using a bunch of plastic and then the plastic's not lasting very long, and if it's not recyclable, it's got a huge problem. Yeah, so the actual material is a bit of a limitation of this, a bit of a worry. There's one there. Yeah, that doesn't have travelator brakes on it yet, so that's a definite negative if you've got travelators and something that we'd have to update in the design. All right, cool. So there's some negatives there. Everyone's pretty comfortable with negatives. One last one? No? Yeah?
That design looks like we only hold one kid in the kid's seat. What if you have two kids? What if you have twins?
Yeah, limitation of one kid in the kid's seat. So most of the Woolies trolleys have just come out with 2 kid seats, so I'm not sure whether everyone's running around with 2 kids in the 2 kid seats, but anyway, 1 kid. All right. Now, this one's a little bit more complex, but red hat people, how did you go? Did you come up with any emotional response to this trolley? It stinks. You don't like it. That's valid. It looks like a kid's trolley. It does. It looks... Yeah, it kind of... It invokes sort of a childish feeling.
It's just ugly.
It's ugly. We don't like the look of it. Cool. One over here. Don't like the colour and the style? Yeah. Feels cheap. All right, that's actually a good one because if we're trying to build an image around Target, our very fancy clothes shop, then a cheap, childish-looking trolley might not be where we actually want to go with that. Sorry? Yeah, so the feeling, the engineer in us is looking at this and worrying that it's not going to be as strong as a steel one. Now that doesn't matter if we've just engineered it and it's 4 times stronger than a steel one, because if we feel that it's weak, people are going to be tentative about filling the thing with hundreds of Christmas presents and stuff. Like if we're Target, we want this brimming when they get to the checkout because that's more sales. And if people automatically feel worried for its safety and that it's going to crush your child or something, they're less likely to fill it up.
Like, is it going to cause strain on you when you like push it around, like when the wheels work properly? Is it like heavy?
Yeah. So it kind of looks heavy and cumbersome, doesn't it? Yeah? And the feeling is that if I'm pushing this around, that I'm going to have to put in a little bit more work than perhaps for a standard steel wireframe type one. It just seems cumbersome. Yeah, you're right.
Yeah, I reckon like after a while, like after it's been baked in the sun, it's going to be brittle. It's going to snap something off and get choked on it.
Yeah, that's a good point. So if this becomes brittle and has broken pieces, think of, does everyone have like plastic washing baskets? You know how they basically live for about 15 years longer than their use-by date? And you've just got broken handles and jagged shit sticking out of them everywhere. You can imagine this going like that, except little kids trying to bounce up and down in it. Yeah? It's probably not a good image. So that's again an emotion. We're worried that it's going to break. We don't have any evidence for that, but we're worried about it. Anything else before we move on? Yeah. So it looks kind of closed in and inaccessible. It looks hard to put things in, especially if you're in a wheelchair or finding mobility difficult. It's kind of happy colours, yeah. And if you're going to Target, it's nice. Target, like the feeling is, it's kind of brand awareness and it's maintaining their brand on the trolley. Yeah. If they're heavy for one person, then someone's got to push 15, 20, 100 of these around. That's going to be difficult. The steering's a bit rough too, yeah, potentially for a trolley person, that's right. Yeah. Yeah, exactly. All right, so do we see how emotion, whilst emotion is sort of, a bit airy-fairy and hand-wavy, do you see how that's actually contextualised in design? You see how these emotional aspects of a design are actually feeding into the physical aspects of a design. If you are trying to create a product that people are going to buy, use or like, then emotion is very important and you can't ignore that. Do you feel that this is going to be strong enough or good enough? It doesn't matter if you go to a client and give them 100 engineering briefs to say it's strong enough. If they look at it and go, nah, it still looks pretty flimsy to me, you're not going to sell it to them and they're going to make you go back and use more material and remove all of your good engineering that you've done on it. Okay? So you guys fundamentally, at some point in a design process, need to be salesmen because you have to sell it to a manager, a supervisor, a product developer, a company. And so the emotion feeds into that. And if you ignore the emotion in the design process, you're going to spend 6 months and a heck of a lot of your money designing something that you hand to someone and go, oh, that looks like kids would build it out of Lego. You're not going to sell it. So emotion is really critical right from the very beginning for everything, and that's why there's a hat involved in that. Question over here? No, good. All right, what are we up to? We are up to a green hat, creativity. All right, where can we go with this design? How can we improve it, or where might this actually go? Yeah? Yeah, so we could actually add some sort of GPS tracking on this so that we can go to someone's backyard and arrest them for stealing our trolley. Yeah, cup holder would be good. So where are we going with this? So because it's moulded plastic, it's opening up a lot of design options that might be more difficult to implement in steel or something, yeah? What else? Sorry, say it a bit louder. Yeah, you could increase the size of the hole. So the size of the holes is largely dictated by, just what you don't want to fall out. So you can make them bigger, save a bit of material, yeah? Yeah, so you could actually add an electric engine or something, some sort of assist down there. You're not selling the case for it not getting stolen. Anyone else? Sorry? Sorry, I can't hear you over everyone. So you could actually fix up the back wheel pivot and make it handle a bit better if that's an issue. Yeah, so it's very cantilevered at the moment, so if that became a problem you could actually connect it down, but that kind of kills your sleek lines and whatnot, but still, yeah, that's what you would do.
Whilst it would be good to break down plastic, even if you just had
Yeah, okay, so that's good. So a lot of us are worried with the structural integrity of this plastic. So you could actually say, all right, we're not going to go fully plastic like this, but there are reasons to retain some of these plastic design features. So maybe we end up somewhere halfway between this plastic one and a metal one. We take all of the positives that we found about the plastic and remove all the negatives and add the wireframe or whatever, and we can start to get a better design. So the idea of coming out with where we could go with this is actually informing a larger scale design process. If we got 5 options, we came up with some good stuff about plastic stuff. Maybe we have a little bit more plastic in the design of one of the other ones, and that's starting to tell us something. All right, so you see how this process, even for an idea that none of us like the look of, or most of us don't like the look of, is starting to feed into the biggest, larger scale design process elsewhere as well. All right, does anyone have anything? Oh, don't do that. Get bugger off. Cancel. There we go. Anyone have anything else on potential directions with this? Up the back?
Whether red and white swim together, or it looks like we can take it apart, and see the different faces that you can change.
Yeah, that's a good idea. So for this design, if it were to get to a point where it cracked or it's starting to get degraded in the sun, it could be modular. It could have one part that's interchangeable at the bit that breaks or, fades, and the rest of it retains. So a lot of the expense here will be around the wheels and the axles and that kind of stuff. So you could just have the top bit interchangeable if it degrades. That's not a bad idea.
Actually, I think you can market that as a kid's toy, like the one that's not.
You market it the kids' toy? Yeah, well, you can make a small version of it, absolutely.
I mean, like, in bikes, there's a small one.
There's a small one and a big one, yeah?
Yeah, and alright, like, well, one shopping, little kid comes home.
Yeah, so if you're shopping in Target with a kid might actually like the look of this better than a wireframe one. So, there's advantages there and potential directions. All right, so that's enough on our shopping trolley. Obviously, we're not all shopping trolley designers, but hopefully that gives you a little bit of context for where the 6-hat method... Now, we didn't talk about blue hat, but blue hat's basically the guy that makes sure everyone's on task. So if you have a yellow hat person saying this is crap because, blue hat person says, no, you're on yellow hat, focus on that, okay? So blue hat is kind of keeping the peace and making sure everyone's doing their job, because if everyone's doing black hat, we haven't talked about the potentials in the green hat or how it makes us feel, and we've ignored the fact that no one's going to buy the design and all of this kind of stuff. So we need all of those hats addressed, and the blue hat does that. Chances are you can probably tack blue hat on one of the other ones, so maybe white hat manages the group as well or something like that. That's up to your group, okay? But I expect you to implement this 6-hat method for your design. I'm going to ask you to actually write up a little bit or use the information that comes from this in your report. So when you're coming up with design iterations, I'd like you to practice this 6-hat method in your group, okay? It's quite important and it's very useful when you're actually designing something. All right, let's do this. Put you back to there. All right, so that's creativity. We all like to be creative, but largely we just need to practice it, and then we will be more and more creative the more we practice it. Brainstorming is very important. Ideation and sketching is effectively this. So we talked about how important sketching is. Sketching's really important in your group, because if you're trying to communicate a bridge design idea to your group verbally, you're going to be there all day and you're going to end up yelling at each other. All right? It's really difficult to communicate some of these different design ideas verbally or waving your hands in the air. You just got to draw it. You've got to draw it on a page. That's what engineers do. Use sketching because it's really effective and you can start to resolve ideas as a result of it.
Does it have to be that detailed?
No, it absolutely does not have to be that detailed. It can be complete garbage. You should see some of the sketches. So I supervise the motorsports team, and you should see some of the sketches I do. And I'm pretty good at drawing because I have to do this a lot. But some of the drawings that I draw for that motorsports team explaining things to them are complete garbage. All right, just big chicken scratches on a whiteboard. But a sketch only needs to be as good as communicating the idea. All right, if you can draw something that communicates the idea, that sketch was a useful sketch in this context. All right, so long as they understand it and are able to communicate it back to you, that sketch was sufficient for purpose. If it's so bad that no one understands what you're saying, maybe work on your sketching. But fundamentally, sketches don't need to be artwork, they just need to be useful. Cool? All right, and then quick prototyping. So this bridge is going to be really useful because you're not going to build your final bridge first. What would be useful is building a little one out of toothpicks or building part of the structure just to confirm how strong it is. We're going to talk about experimentation, but quick prototyping just to confirm some different things. You can build stuff quickly and learn stuff very quickly from that. And I've got a video that largely highlights that.
Solutions to this problem,
How loud is that?
including services that help you find other people to practice with, and find a coach to help you practice.
So, before I get into that, this is from a guy at MIT. He's a lecturer, and a similar sort of design class like this, but the idea was that they need to design a volleyball server such that he can practice his spikes, or whatever they're called, with volleyball by himself. So he wants to practice as many, the ones where you jump up the net and whack it down. He needs something to launch the ball up automatically so that he can do that. And this is him quick or rapid prototyping. I might even get rid of that if that's in the way. That normally goes behind. There we go. This is him rapid prototyping that, and the actual process involved in rapid prototyping that. All right, so that's some context.
I've brainstormed many solutions to this problem, including services that help you find other people to practice with, and find a coach to help you practice, but I've also explored devices that will launch a volleyball you can then practice with. 3 interesting ideas I came up with include a kicking device to launch a ball, a slingshot device, and a pitching machine volleyball launcher. Now that I've picked an idea that I want to explore further, the next thing an engineer will typically do is make quick prototypes to figure out more details about their solution. Quick prototypes are useful because they don't invest a lot of time or money, and they keep things flexible so that you can explore other solutions as well. What I have here is a prototype made of cardboard that's going to help me explore the kickball volleyball launcher solution. So it's basically just a cardboard structure with a hammer that's going to act as the kicking force for launching the ball up into the air. So after you've made your models, the next important step is to test them out. That way, you can figure out a little bit more about where your project should go. Some important questions that you hope your model will answer are things like, does my idea even work? Do I need to talk to users some more? Is it worthwhile to make a more refined, more expensive, and more time-consuming prototype? Those are the kind of things that you hope a good model will answer. So to test this one out, I've gotten into a room that's got a little bit higher ceilings, so we can see what this thing can do.
Yeah.
So even though that was a lot of fun, we actually learned a lot from this prototype, even though it wasn't that expensive or durable. One thing that I noticed is that it's kind of difficult to get the hammer to impart some momentum on the ball and launch it up into the air. Another thing that I noticed is that the ramp kind of has to be designed pretty well. Otherwise, if the ball hits it, it's not going to get launched up into the air. Finally, another thing I noticed about this idea is that by design, it's not really that portable, because it's dependent on lugging around a big heavy weight. So that could be a problem if you want to take this thing out to a volleyball net. Based on the things that I've learned, I've actually decided to switch from a kickball launching method to a slingshot method. Remember how I mentioned that you don't always get it right the first time through. Because this video is a little bit short, I don't have time to go through another model at this level, so we're going to skip ahead to a more refined prototype. Okay, so here's our more refined prototype. It's made of wood, so it's a bit more durable than the last one, and it's going to help us find out a little bit more about the slingshot solution. So the way that this prototype works is that these elastic bands up here will act as the slingshot with these 2 posts. And this hook is going to connect to a pin that goes through these holes right down here. Then, when the pin gets removed, the ball should get launched from this funnel. So let's see how well it works. So even though this prototype worked, am I done? Absolutely not. There's still a lot more to do. I could do stuff like improve the model by talking to users and see if it actually meets their needs. I can make it a little bit more user-friendly and easier to use. I could add some more features, something like a ball feeder so that you can have multiple balls and then it launches them one at a time. There's still plenty of things to do. Keep in mind that the design process is actually an iterative thing. So you'd go through it over and over again until you arrive at something that's ready to go to market. I hope you learned a bit about the design process and you hope to go out there and design something yourself. Okay.
All right, so that's just a little example of what rapid prototyping can get you. I mean, in the context of engineering, what I always love doing or love having students do for things like the motorsports car, we do lots of rapid prototyping. Now that might be as simple as cutting things up out of cardboard and making sure they fit, or it could be 3D printing things to make sure it actually integrates with other bits of the car, other components, and anything in between, cutting things out of styrofoam and making shapes, cutting things out of wood, that kind of stuff. Rapid prototyping is really, really useful, all right? And you guys will learn quite a bit about your bridge design by actually doing some really small-scale stuff, starting to build things, starting to think about different structural techniques. You can do a scale model of your scale model out of paper or something and fail it and work out the mode or mechanism of failure. All right, and that'll tell you stuff about your design and ways to improve it. So rapid prototyping is a really useful thing in this phase of the design project. All right, so what's the time? I got one slide left and then you guys can have a bit of a go at analysing, because the very beginning of the analysis phase, step 4, is to assess your designs that you came up with in step 3. Now, what you want to do is start doing that right whilst you're in the design phase. So in the phase 3, you want to start assessing. So the 6-hat method is setting the groundwork for that. And so all I've got on these slides is what we call a decision matrix, okay? And so this decision matrix you can use then, and then once you've done detailed analysis and experimentation and various other things, you can use that decision matrix again. But we're going to have a bit of a look at the decision matrix now, right? So, hands up who's seen a decision matrix before? A couple of you? Good. All right. So a decision matrix is effectively a way to decide whether something's, or decide between a few designs, right? And you will have design criteria that you need to meet. And so on a decision matrix, our design criteria, if my mouse shows up, are down this column here. All right, so this is some particular design that I'm assessing. I've got 2 different designs, design 1 and design 2. And the design criteria are safety, durability and cost. What are some design criteria for your bridge? Durability, yeah, so weight carrying ability largely. So we need this thing to carry 30 kilos and it needs to basically not break the whole time. What else? Sorry? The weight of the bridge, so how light is it? Cost is going to be very important because you guys are bankrolling this show. So, you know, $1,000 bridge, not applicable. $20 bridge amongst 5, probably a bit closer to the mark. Loading mechanism, yeah, so how good is the loading or how easy is it to load, that sort of thing. What else? How easy is it to transport and set up? That's a good one, because you need to get it to where I want you to test the bridge, which will probably be out here if I book it in front of Miss Sushi there in that undercroft. What else? What about how easy is it to build? You guys are building it yourself. How easy is it to actually put the thing together? All right. So those are the sorts of criteria that you might be assessing your bridge, but you might come up with more. Which one's the most important? Weight, maybe? Yeah, so weight's most important on the marking criteria. Is weight more important than cost? Probably not, depending on where your cost range is. Yeah, so some of the criteria will be more important than others, and that's where this decision matrix comes in, right? So this next column is weighting. How important is a particular criteria? In this example, Safety is very, very important. Durability, medium important. Cost is fairly low priority. So we're fairly insensitive to cost. Okay? Then you give each design a score, and that can be a score out of 10. It's all relative. So whatever you're scoring out of, you just say, all right, we're scoring out of 10, and you just give it a mark. All right, so design 1 out of 10 is very, very safe. 8 out of 10 is quite safe. Yeah? Design 2, 5 out of 10, not as safe. But still, better than some designs. Next thing, durability. Design 1, 2 out of 10, that's not very durable at all. All right? So it's probably going to break pretty quick. Design 2, 6 out of 10, that's more durable. Certainly more durable than design 1. Cost, 1. Now 1 out of 10, would that mean it's very expensive or very cheap? Very cheap? Basically, if you get a score in this, a good score in this should mean it's something you want. So a high score should be something you want, and a low score should be something you don't want, because a high score will mean you choose that. So cost, if cost is very low, that's a good thing. So we want a high mark for that. If cost is very high, that's a bad thing. We want a low mark. Does that make sense to everyone? Yeah? So if we have a score for design 1 of 1, what does that mean the cost of design 1 is? It's very expensive. Now design 2 is 5, so that's sort of middle of the road. Okay, now let's forget about weight for a second. If we just had a weight of 1 in each of those rows, the score for design 1, you just add up 8 times 1, 2 times 1 and 1 times 1. What do we get? 11. What about design 2? 5 plus 6 plus 5? 16? Alright, so which design would we choose if our weights were 1, 1 and 1? Higher mark is better. Design 2. But what we've just said is that safety is much more important than the other criteria. Alright? And we know that design 1's much safer, and so where these weights come into it is that they multiply. So 8 times 60 is 480. 2 times 30 is 60. 1 times 10 is 10. And you add up the weighted score, you get 550. And over here you add up 5 times 60 is 300 and so forth. Add up the weighted score, 530. And you can see where before we chose design 2 with an even weighting, now we're choosing design 1 because that higher importance on safety has come into it. All right? So that weight column is very important because the weight basically enforces our criteria, how important we feel something is. Okay? Now the weight doesn't have to be out of 100 like this. You could have 3, 2 and 1. Or you could have 100, 50 and 0. All right? It doesn't matter because it's relative. And it also doesn't matter what scores you give the designs because again that's relative. You just end up with a relative number that you can compare at the end. Okay? So the weights, whether they're out of 10 or 100 or percentage or whatever, doesn't matter so long as you use the decision matrix correctly and you'll get a relative number at the end. The highest number is the one that you should choose. Okay? So decision matrices are very useful for choosing between designs. You will be required to do one in the quiz for this subject. Okay, so you need to learn these. For the rest of today, what we're going to do is this. You guys are graduate engineers and you get to choose a car. You're going out and you've got nice big high graduate engineer salary and you need a new car and you're going to choose one. All right? And instead of just going and choosing one based purely on emotion, which most of us will, you're going to create a decision matrix. All right. So you need to write this out and the first thing you need to do is stipulate a weight. So size of the car. How big is the car? Is it a big car? Is it a little car? And how important is that to you? Do you not care how big that car is? If you don't care, then its weight probably should be low, like 1. If you're really specific about weights, then you want a high priority on that, so that's a 5. And then when you go to give a score, if a big car is important to you, then a big car gets a high score. If a small car is important to you, then a small car gets a high score. Yeah, so basically what you want gets a high score, what you don't want gets a low score. Next thing, Fuel efficiency, how important is that to you? Give it a score and then assess each of these based on their fuel efficiency. Cost, how important is cost? If you're a high-rolling graduate engineer, maybe cost isn't as important as if you're a uni student, but for most of us, cost is pretty important. It's probably one of the major defining characteristics of buying a car. Aesthetics, how important is what it looks like and then how good do they look? Performance, how important is that? Safety and so forth. So give each of these categories a weight and then go ahead and give them a score and work out which car it is out of these, whatever, 5 it is that you want to buy. This is your opportunity to ask me how a decision matrix works before you will have to do them in this design project and the exam, okay? So if you don't understand how a design matrix works, please try this and ask me questions. We'll spend the next 10 or 15 minutes on it and then we'll have a quick discussion and be done, okay? Alright guys, it looks like some of you have finished your assessment of each of these car types. Show of hands who, based on their decision matrix, would be buying a Holden Commodore. Some of you? Show of hands who would be buying a Ford Falcon. Couple? Subaru WRX? Yeah, a few more. Good. Toyota Corolla? Some of you? What about Cooper S? Couple. Okay. So does what you got from the decision matrix largely align with what your personal preference is? It should do in this circumstance for the most part. Yeah. So this is my one. This is in the notes. You can look at it. As that suggests, Subaru WRX would be my ideal, then probably a Corolla, then a Commodore, then a Falcon, and a Cooper S doesn't really appeal to me at all. Yeah? That's a small car and I have 2 children. It would not work the least. So, and that largely aligns. I have an Impreza RS, so that's pretty close to what I drive already anyway, minus the extra fuel consumption. So that's pretty much it. So that's how you use that. This is important. I expect every single design report to have at least one decision matrix in it, used correctly. Okay? If you do not have a decision matrix in your design report, you will lose significant marks. Not like fail marks, but still it will be worth significant marks, okay? So what you want to do is tomorrow for the tutorial, we're going to be going through that brainstorming process. You're going to work in your group in the class. We're largely just going to tick off attendance and you're going to work through brainstorming ideas and implementing decision matrices there with us there to help you once again. And then you need to incorporate that decision matrix into your final report. Now, the last thing I'm going to do today, and it's going to take half a second if I get it out here, I'll just show you what you're actually filling out, okay? This is on LearnJCU. This is your design proposal. All right, so this is the little document that you need to fill out based on all of this discussion we've had today in the tutorial that you do tomorrow. Again, you'll have a purpose statement and then you'll have 3 designs, a minimum of 3 designs. And you want to provide a sentence introducing design, provide detailed drawings of the structure or any photos or any ideas, any sketches, general concept for the design you need to document. Any references where you got those need to be in there. And then you need to detail the strengths and weaknesses of the design. And that's what you identify through the 6-hat process. All right, so document that 6-hat process. And then, I haven't put on here, but I might update it. In the conclusion to this section, I want a decision matrix. Okay, so you'll have a 1.4 conclusion decision matrix in that. Okay, and maybe a sentence that says, based on this, we will choose that. All right? So this is the section that you need to get enough information and discussion together tomorrow, and your progress for tomorrow will be basically what's marked. As of next week, we'll start to actually mark real things that you do, but up till now, I just want you to be working in your groups and working on this project and getting as far as you can in the class time provided. Okay? Any questions? No? Great. Have a good one.